Welcome to Q&A Wire.
We're given that in the time of 1 second, 2.68 times 10 to the 16 sodium ions, which are positive, flows to, seems that I've made a mistake here, flows to the negative electrode, and 3.92 times 10 to the 16 chlorine ions, which are negative, flows to a positive electrode. And we're asked to find the current between the electrodes. So first, we'll use this formula that the current is equal to the total charge that's flowing divided by the time in which that charge flows. So it's up to us now to determine the total charge. So we determine how much charge is carried by this concentration of ions, or these number of ions rather. So for sodium, so let's write the charge. So this is the charge for sodium. It actually has a magnitude of the elementary charge times the number of ions. So that is 2.68 times 10 to the 16. And the elementary charge is 1.6 times 10 to the minus 19 coulombs. And in a similar way, we figure out the number of chlorine, the total charge of chlorine, which has the same magnitude, times 3.92 times 10 to the 16. So it has the same magnitude. However, this charge is positive, and this total charge is negative. And Q, but I don't put a negative sign here, and I'll tell you exactly why. Q is the total charge is the sum of the charges that we have for the ions. And we add them up because of the way that the current is defined. So rather, let me just say that I'm defining the current already. And the current is defined as the way the positive charges flows. So if the positive charges are flowing in one direction, it's the same as the negative charge flowing in the opposite direction. And that is why we add up the charges, because they have the opposite sense of directions for the positive and negative charges. So therefore, it's as if we have a current in the same direction for each one. So the current given by the sodium ions has the same direction as the current given by the chlorine ions. So we have elementary charge times 2.68 times 10 to the 16 coulombs plus 3.92 times 10 to the 16 coulombs divided by 1 second, because that's the time we're given. And you find that this is 0.0106 amperes, which is 10.6 milliamperes. And now we'll move on to part B, which we actually answered already, that the current is the flow of the positive charges And we're told that it flows towards the negative. So the direction of the current is from positive to negative.